Hello guys, myself Mahendra RM, and today I am going to explain you about how to generate object code for given SIC/XE programs. Here this is the given program for SIC/XE. Here they given label, opcode and as well as operand for each and every instructions. We need to find out the location counter and as well as object code for each and every instruction. Before going to object code, let's we need to know about the instruction formats for SIC/XE architecture. Here SIC/XE it is mainly consisting of four different type of formats, that is format 1, format 2, format 3 and as well as format 4. Here format 1 which is of 8 bits, it consisting of only opcode. Next format 2, here format 2 which is of 16 bits. Out of 16 bits it contains 8 bits as opcode and 4 bits and as R1 and 4 bits as R2. Here R1 and R2 are registers. Next format 3. Here format 3 which is of 24 bits. Out of 24 bits we are having 6 bits for opcode, next 6 bits for addressing modes and next 12 bits for displacement. Next format 4. Format 4 it is consisting of 32 bits. Out of 32 bits, we are having 6 bits for opcode, next 6 bits for addressing modes, next 20 bits for addresses. Here addressing modes are having only one bits. Here n is nothing but indirect addressing mode, I is nothing but immediate addressing mode, x is for indexed addressing mode, b is for base relative addressing mode, p is nothing but program counter relative addressing mode. Here E is set to 1 if it is format 4, or else E is set to 1, E is set to 0 if it is format 3. Now let's come to location counter. How to find out the location counter for each and every instructions. Now let us consider clear X, which is consisting of starting address, that is 3000 as a starting address. Let's come to clear X, which is the first instruction, which is of format 2. Therefore, we are incrementing the location counter value by 2. Therefore, we are getting 3002 as a next location counter. Next, LDA as 0, which is of format 3. Therefore, we are incrementing the value by 3. Next, for 3002, we are adding 3. Next, we are getting 3005 plus LDB as total, which is of format 4. Therefore, we are adding 4 to next location counter. Therefore next we are getting 3009 as a location counter. Here for base we are not find out any location counter. Next add table comma x, which is of format 3. Therefore we are adding 3 to this 3009. We are getting 300 c as location counter. Next tix count and jld loop sta total, these three are all belongs to format 3. Therefore we are keep on incrementing the value by 3 up to here. Next let us consider resw1. Resw is, it is nothing but we are reserving the word is nothing but 3 bytes. Therefore we are reserving the only one word here. Therefore we are multiplying a 3 into 1, we are getting a 3. Therefore we are incrementing the value by 3. Next we are getting 3018 as location counter. Next instruction is resw 2000. resw, therefore word, we are reserving the word with the value 2000. Therefore we are multiplying the value 3 into 2000, we are getting a 6000, which is in the form of decimal. We need to convert it into an hexadecimal value. If we convert 6000 into an hexadecimal value, we are getting 1770 as an hexadecimal value. Next we need to add this 1770 with an this address, that is 3018. Next if we add, we are getting location counter as 4788. For this one location counter as 4788. Next we are reserving the word with the only one value 1. Therefore 3 into 1 we are getting 3. Next we are incrementing the value by 3. For 4788, if we are adding a value 3, next we are getting 478b as location counter. This is a given table for mnemonic and as well as opcode for each and every mnemonic. Next, let us come to a first instruction, that is clear x. Here clear x, which is of type format 2. Here format 2, which is consisting of 16 bits. Out of 16, opcode is 8, remaining 8 for 2 registers. Now let us consider opcode. Opcode for clear is given in this table, that is clear. Clear, it is nothing but B4. Here clear is nothing but B4. Here B4, we are writing a B4 in binary values. For B we are writing 1011 and for we are writing 0100. Next, let us consider, here we are having register as x. X is having a value, that is for register value is 1. Therefore for R1 we are writing a register value as 1. For R2 we don't have another register, therefore R2 value is 0. Now to find out the object code, we need to group 4 bits together. For 1011 is nothing but B, 0100 is nothing but 4. Next we are getting 1, next we are getting 0. This is the B410. This is the object code for first instruction, that is clear x. Next, LDA-0, which is of type format 3. For format 3, it is having totally 24 bits. Out of 24, 6 as opcode. For LDA, let's see this table. LDA, it is having opcode as 00. Here in format 3, we are having opcode only with 6 bits. Therefore, we need to consider only 6 bits. For 00, for first 0, we are writing 0000. Next 0, we are writing only most significant bits, that is 00. Next, here LDA as is nothing but it is an immediate addressing mode. Therefore, we are setting I value is to 1. Next n value is 0, x value is 0. We don't have any of this, therefore we are setting remaining all the values as 0. Next, displacement is 12 bits, which is all are set to 0 because we don't have any value here. Therefore, to find out the object code, group the 4 bits together. If we group together, we are getting a object code as 010000. Therefore, this is the object code for LDA as 0. Next, let us consider next instruction, that is plus LDB as total. Here we are having a plus. Plus is nothing but which is of format 4. Therefore, here format 4, which is consisting of 32 bits totally. Out of 32, 6 bits for opcode. Here opcode for LDB is given in this table, that is LDB, which is nothing but 68. We are writing a 68. We are writing first. We need to consider only most significant 6 bits. For 6 we are writing 0110. For 8 we are getting 10 as 10 as a most significant bits. Now let us consider next addressing modes. Here we are setting LDB, it is having as total. As is nothing but immediate addressing mode. Therefore we are setting I value is to 1. Remaining all are set to 0. Here E is set to 1 because which is of format 4. Next, let us consider address. Address is nothing but here hash total. Where the hash total it is present in which address, which memory location hash is present. We need to find out that total where is present. Here total it is present in 4788. Therefore, we are setting the address values 4788. We are writing 4788 in the form of binary. Therefore, now the next we are grouping all the 4 bits together. For next we are getting a object code as 69104788. That is 69104788 as object code for this instruction. Next, base it does not containing any object code. Next, let us consider an next instruction, that is add table comma x. Here add table comma x, which is of format 3. Here format 3, it is consisting of 24 bits. Out of 24, 6 is most significant bits, that is opcode. Next, the remaining 6 for addressing modes. Next, 12 for displacement. Now let us consider opcode for add is given in this table, that is add we are having here 18, that is for 1 we are writing for 1 we are writing 0001 in the binary form. For 8 is nothing but it is consisting of 1000, but we are taking only two most significant bits. Next, for addressing modes, we are set which is of table comma x. Comma x is there, therefore it is nothing but it is an immediate indexed addressing mode. Here it is of the format, it is containing a which is neither indirect or immediate also. Therefore, we are setting these three addressing modes to 1. Here E is set to 0 because which is not format 4. Next, we need to find out the B, which this format is of base relative addressing mode or program relative addressing mode. We need to find out the in to find out the B and P. We need to consider displacement formula. That is, displacement is equal to target address minus program counter. Let us consider target address. Target address is nothing but where the table is present. Here table is present, it is in the form in the location counter, that is 3018. Therefore minus PC. PC is nothing but address of the next instruction to be executed. Now let us consider add table comma x. This is the instruction. Address of the for PC for this instruction is address of the next instruction, that is 300C. Therefore we are minusing these two, we are getting C. If it is in the form of hexadecimal, we convert into an decimal form, we will getting 12 as a result. Therefore this value 12, which is in the range between minus 2048 and plus 2047. Therefore we are setting value P to 1. Therefore B is become 0. Therefore we are getting displacement as C. Therefore we are writing for displacement which is of 12 bits, we need to write it is in the form of binary values, that is 00C. Now let us consider object code for this add table comma x is given as 1BA00C. Now let us consider next instruction is tix comma count, which is of format 3. In format 3 we are having 24 bit at 24 bits. Out of 24, 6 is for opcode. Here opcode for count is given as in this table count. Opcode for count is 00. Opcode for count is 2. Opcode for count is given in this table. Okay. Next 2, we are writing a 2 in the form of 0010. We need to take only most significant bits. Next let us consider which is of this instruction which is neither immediate nor indirect, therefore it is not indexed, therefore we are setting x value to 0, which is not format 4, therefore we are considering e value to 0. Next we need to find out whether it is base relative or program counter relative. To find out the displacement, we are having a formula called displacement is equal to TA minus PC, a target address of count where the count is present. Count is present in 3015. Therefore, address of the next instruction to be executed, that is tix comma count. Tix count next address to be executed is 300F. We are minusing these two. We are getting our answer as 6. Here this 6 it is in the form of x value, therefore we need to convert it into a decimal. We will get 6. It is in the range of minus 2048 and 2047. Therefore we are setting the p value to 1 and b value to 0. Next we are grouped for 4 bits together, we will get object code for tix count. Therefore object code for tix count is 2F2006. Next format is JLT loop, which is of format 3. Therefore, let us consider format 3 JLT. Object code for JLT it is given as 38. 38. We need to take only most six significant bits. Therefore, this is the 38. For 38, we are getting most significant bits as this much. Therefore, n is set to 1, I is set to 1, x is 0. We need to find out b and p. E is set to 0. For find out the displacement, we are having a formula Ta minus Pc. And target address of loop is, let us consider loop. We are having a loop is here 3009 minus, we are getting the PC. PC is nothing but, for JLT PC value is 3012. Address of the next instruction to be executed is 3012. If you minus these two, we are getting FF7. Here FF7 it is in the form of X value. We need to convert into an decimal value. We need to check whether this value it is in the range or not. It is in this range only. Therefore, the P value is set to 1. Next, B value is set to 0. Therefore, FF7 it is the displacement. For F, we are writing in it is in the form of binary. For F, we are having triple 4 ones. For F, in another F, we are having 4 ones. For 7, we are writing it is in the form of 0 1 1 1. Therefore, after group put together the 4 bits, we are getting 3B2, that is 3B2 FF7 as the object code for this JLT loop instruction. Next, consider an STA total. STA total which is of format 3. Therefore, we need to find out the displacement also. Now let us consider opcode for STA. It is given in 0C. 0C it is a opcode for STA. For 0C we are taking only most significant bits. That is, for 0 we are having 0000. Next, for C we are having 1100 in the binary form. We need to consider only first two. Next, Ni is set to 1 1. Here he is set to 0, X is set to 0. We need to find BP. Next, to find out the displacement, we are having a formula called displacement is equal to Ta minus Pc. Here Ta is target address of total, where the total is present. Total is present in this location counter, that is 4788, minus PC. PC is nothing but address of the next instruction, that is 3015. 3015. We need to we are getting a result as 1773. We need to convert it in decimal. We are getting as 6003, which is out of the range. Therefore, we need to consider another formula for find out the base. That is, displacement is equal to target address minus base. Here target address value is same. For to find out the base value, let us go to base. In the base, we are having a total. Where the total is present, here total is present in this location counter, that is 4788. We need to minus these two. We are getting displacement as 0. Therefore, we are writing a displacement as 0. Here we are finding out the displacement using base relative addressing mode. Therefore, B value is set to 1, P value is set to 0. Next, we need to group the 4 bits. We are getting the object code for STA total as 0F4000. Next, let us consider next. Now, let us consider for reserve word. For next 3 instruction, no need to find out any object code, because next starting address, next end, and for reserve bytes, no need to find out the any object code. Now let us consider last one is end. If you For end also no need to consider any object code, but if you want, we can write as starting address for this. Starting address as the object code for end. Therefore, these are the object code for given set of instructions. Next, for the find out the next for to find out the object program for given SIC/XC program, we are having in the object program we are having three different types, which is nothing but header record, text record, and end record. Here, header record, in the header record, we are having a total 19 columns. Out of 19 columns, first column is represented using H value. Next, column 2 to 7 we are representing the using program name of the program. Next, column 8 to 13 starting address of the program. Next, column 14 to 19 length of the program in bytes. Next, let us consider a text record. The second type is text record. Here, text record having column 1 is T, column 2 to 7 as starting address. Next, column 8 to 9 as length of the object code in this record. Next, column 10 to 69 is object code. Next, end record. In end record, we are having only total 7 columns. Out of 7, column 1 is T, column 2 to 7 is address of the first executable instruction. Now let us consider object program. First one is header record. First column is represented using H. Next, name of the program is sum. Now let us consider remaining 3 bits are set to empty. Next, let us consider name of the program after we are having starting address of the program. Here, starting address of the program is 0003000 as a starting address. Next, let us consider length. To find out the length, we are having length is equal to ending address minus starting address. Here, the ending address is 478B and starting address as 3000. If we minus, we are getting length as 178B. Next, this is the header record. Next, let us consider a text record. Text record column 1 is T. Next column is represented as starting address of the program. This is the starting address. Next, column 8 and 9 is represent length of the object code in bytes. Next, this up to 10 to 69 we are having object code. Here, whatever all the object code we are find out, we are writing here. To find out the length, we need to group 2 to 2 object codes. Therefore, we are getting 15 as the length of the text record. Next, let us consider an end record. In the end record, column 1 is E represented using E. Next, column 2 to 7 we are having starting address of the first executable code, that is 3000. This is the object program for given SIC/SIC program. Thank you.